Awesome. Okay, so yesterday we learned the rules, right? Just the basic ones. We reviewed them from Algebra 1, Algebra 2. And then we went through some examples. And so what I want to do is add one more rule. So on the back of your paper at the bottom, I need you to add one more rule to it. Actually, can I move it? Yeah, down here at the bottom. I want you to add one rule. Right down here. This is the last rule. Oh, by the way, can y'all see my shirt? Exponents are number, what's anything to 0 power? Exponents are number 1. You're not supposed to know that. Okay, never mind. Never mind. Doesn't work if you don't know anything. It don't. Baby, it does. There's no excuses. No excuses. All right, so the rule we're going to learn now is the one for if we have roots. Oh, I was supposed to play the song. I'll play it at the end because y'all ain't got no roots. But if we have roots, so if you have something where it is this, it's a root sign, and it's not just square roots. It has some number in, and then the base, whatever the base is, we have some base, and it is raised to the m power. Now, roots are what? Are they down? Right? And raising a power is, raising is up. So raising, the power we're raising to goes on the top, and the root goes on the bottom. Make sense? So this is going to become b to the m over n power. And why did I do that? Because the root goes down, and the power which we raise something to goes up. It's that simple. Oh, nice, gentlemen. Come in. We just started notes. So everybody got it. That's all we're doing. That's the only thing I'm adding. Oh, wait. Are all those other things still in play? So now you have to remember what happens when I'm multiplying things with the same base, when I am dividing things with the same base, when I'm raising a power to a power. All those rules still come into play. And on top of it, we now have fractional roots. Okay? So let me add a page, and we'll do some of your problems. Like, so, do you know the second worksheet? Look at the second worksheet. You got it? I'm inserting a page for us to use. Right here. So, look at I want to do number 8. Go find number 8. No, I didn't. I want the one with 8. Go find number 1. Ever see number 1? Look at number 1. Oh, I think I want a different color. I want number 1. For number 1, do you have 8 to the, what's the power of 8? Huh? 2/8? Hang on a second. Let me write it down. And there's that better? 2/8 over what? 8 to the what? 1/8. Are those the same base? Is that the same base? Yes? If it's the same base and we have division, what do we do with powers? Add when we're dividing? Yeah, thank you. So this is going to equal 8 to the 2/8 minus 1/8. Was I really nice to you? Because 2/8 is really 1/4. But I didn't want you to have to think too much first period, Jerice. Maybe you should get off the phone. It would make it easier. Right. So did I leave it in eighths so it'd be easy to subtract? What's 2/8 minus 1/8?
1/8.
So is this just going to become 8 to the 1/8? What does that look like if we write it as a root? Because I need you to be able to go back and forth, right? So what would it look like? Not the root sign, and what am I doing the root sign of? 8, and what's the base? 8, right? The 8th root, right? Does everybody see how to write it? These mean the same thing. Do y'all need to get there in a hurry? Yes? Okay, that wasn't too bad, was it? I wouldn't say it was easy, but it's not too bad. In order to do these, remember how I told you you had to know your squares and cubes? Let's go through the cubes. For cubes, you need to know 1 cubed is what? Sorry, that's a bad 3. Now, Therese, really? 2 cubed is what? 3 cubed is what? 4 cubed is what? 5 cubed is what? 6 cubed is what? 216, thank you. And 7 cubed, if you just happen to need, was 343. I remember it because it's just a weird looking number. The symmetry. I like symmetry. Do you need to know those? Yeah. Look at number 4. We can do this the hard way, we can do this the easy way. So first we're going to do it the hard way. So for 4, if you have, is it cube root of 8 cubed? Right? Now, I could switch this around. I don't want to cube 8 and then take the cube root. I really don't. I'd like to do it the other way around. And then there's a shortcut on this. I'll show you the shortcut in a minute. But first I want to show you when you get to things that you never want to make them bigger and then smaller. Taking the root makes something smaller, right? So I want to rewrite this. Is this the same as saying the cube root of 8 cubed? I want to show you this trick on this. This is not necessary for this problem, but I'm using it as an example. What is the cube root of 8?
2.
It's 2 because this is the cube root of 2 cubed, right? Look at all the symmetry here. Is that going to be 2? And then 2 cubed is just 8. And how could I have gotten there faster? If I wrote this a fraction, instead, what if I did 8 to the 3 over 3? Is that just 1? Is it just 8? Is that the shortcut? But I wanted to show you this trick because I want you to see that anytime you have something like this and you can actually, it's a perfect cube in here of some sort, you always want to take the cube root of the perfect cube before you go raise it to any other power. They're going to write it like this, but this is the way you should write it if it's a perfect cube. Do you understand what I'm getting at? Because if it's a perfect cube, you can make it get smaller before you go and make it bigger. Right? That is so much better. Yeah? Okay. Look at number 8. Number 8. We have 81 to the negative 1/4 power. Okay, does that mean it's 1 over the 4th root of 81? Now, what is 81? Is that 9 times 9? And what is 9? Is that 3 squared? Okay, so is that 3 squared times 3 squared, which would be what? Watch what I'm going to do. This I can change to 9 times 9, right? Which equals 3 squared times 3 squared, which is 3 to the 4th. Yes? So what do I get? I get 1 over the 4th root of 3 to the 4th. Does the 4th root undo the 4th power? So what do I get? 1/3. Do I need you to do that? I do. I'm sorry. You'll need to see all of it. Let me put this a little smaller. Yeah? I'm going to add another page. Do you see that I'm doing a smattering of each kind for you? I'm trying to give you a little hint here and there on everything. Got it? The next one I want to show you is 15. Is this using the fractional roots and all the things we learned yesterday? So it's 3x to the 1/2 power times x to the 3/2 power minus 3x to the 1/2 power, like so. So from yesterday, there's not much you can do until you distribute this, right? You're going to have to take this and you're going to have to multiply these like so. Yeah? Let's see what happens when we do that. What are we going to get? We're going to get 3x to the 1/2 times x to the 3/2 minus 3 times 3 is 9, right? X to the 1/2 times x to the 1/2. What do we do with powers when we have the same base and we're multiplying? What do we do with their powers? Add them, right? What's 1/2 plus 3/2? 4 halves. And what's 4 divided by 2? Does that just become 3x squared? Minus 9, what's 1/2 plus 1/2? Is that just x? Are we done? That wasn't that bad, was it? Is it going to take practice? Okay, 16. We got a couple more I want to do to make sure you remember them. Is 16 just like the ones we did yesterday, and now they're fractional powers? Hang on, I want to change to black. There we go. If x to the 1/4 power minus 4x to the negative 1/4 power over x to the negative 3/4 power. Is this messy? But if you will take this and break it into two fractions, will it make it faster and easier? It would. So I'm going to end up with, okay, since I'm doing division, let's write this out though. Let's do x to the 1/4 divided by x to the negative 3/4, and we'll deal with that in a minute, minus 4x to the 1/4. Is that a negative? Sorry, it's negative 1/4. It's negative 1/4, right? I put the negative right there for that. And then it's x to the negative 3/4. The first thing I need to do, I need to move the negative powers. Things with negative powers, how do I make them positive? Am I going to move this one up, this one down, and this one up? Right? But the 4 is going to stay the same, and this is going to stay the same, right? Don't move those, just move the ones with negative powers. So what does this become? This is going to become x to the 1/4 times x to the 3/4, right? Minus 4x to the 3/4 over x to the 1/4. What do I do with these powers? What's 1/4 plus 3/4? And 4/4 is just x, right? Minus 4. What's 3/4 minus 1/4? And what's 2/4 reduced to? 1/2. And we're not going to leave it like that. It's going to become x minus 4. If I write this as a root, is it just the square root? See it? Okay, my advice to you on 31 is reduce the things inside before you cube them. Do you understand what I just said? Look at 31. Reduce, go ahead and simplify the inside the parentheses before you try to raise it. Remember, you always want to make things smaller before you make them bigger. Do the inside first. Okay, real fast. That's enough for today. I need to take